Okay. So yesterday, what did we discuss? So I started with the problems of the traditional IT infrastructure, and after that, how we have overcome all those problems. That is what we have discussed. And after that, the cloud history we have discussed. And after that, we were discussing about the IaaS, PaaS, and the SaaS, and we have seen examples for that. Okay. And after that, we were trying to understand the data center part actually. Okay, and after that we understood the infrastructure in the Azure, right? So they have more than 200 data centers across the globe, um, and why they are spreading across the globe. I'll talk about that one also today. Okay. Huh. Now you guys know that data center. You guys are very clear with the data centers. Now it's time to understand what are all the things are there inside the data center. That is what you need to understand. Okay. So if you observe here, the systems are arranged in a arranged like a racks. This is one rack, I can say, from here to here. From here to here, this is one rack. Okay. All these are systems only. Servers, I can say servers. All these servers are actually are in a box, kind of almara here. Okay. Uh, what I can say is this one I call it as a rack, RACK, rack. Okay, so this is the example for that. This is kind of rack. That rack I call it as a fault domain. Fault domain. And one more thing is, okay, in a rack, you may have 15 to 20 servers nearly. There is no hard limit on that one. You may have 15 to 20 missions. Okay, and all these machines actually connected with the same power supply, same network switch. Same power supply, same network switch. Okay, like that, for every rack, separate power supply, separate network switch will be maintained for every rack, for every fault domain, I can say. Siva, why are they maintaining like that? What is the reason for that? Any clue? Okay, let me move on here. You know what will happen here? If all racks are connected to the same power supply, what if the power supply goes down or something happened to the power connection actually? Then what will happen? All the servers in the data center will go down actually. So what they will do is they will try to connect these fault domains or racks to different power supply connections. One is for the backup power supply, one is for the another backup one is for the main supply. Like that, they'll try to connect to each and every rack to the separate power supplies here. So that even if something goes wrong with one connection, overall power supply issue is there, then all the racks will go down. But if you have an issue at the individual power supply level, I mean, individual connection level, then your servers will not go down. All the racks will not go down at the same point of time. So with that, what they are trying to achieve is fault tolerance. They are trying to achieve here. Okay. So, and that too, one more thing is, okay, I think we'll discuss that one, the update domain in the next one. Okay. So what I was trying to say is 15 to 20 servers, we call it as a rack. Each rack is connected to separate power supply and the network switch. If something goes wrong in the power supply and the network switch, there is no chance of going other servers down. There is no chance of going other racks down. Only that particular rack will go down, so that the services will not get interrupted here. That is what I was trying to say here. Okay, that means in your data center contains actually group of racks. Data center is a collection of racks, I can say. Okay, in each rack, 15 to 20 servers. At a high level data center, like inside a data center, you will be having like um, uh, uh, racks. Inside the rack, actually, you'll be having 15 to 20 servers. Okay. Now, again, that particular rack, I'll try to call it as a, okay, inside the like rack, we'll be having update domains. What do you mean by that? What do you mean by update domain? Okay. See, I told you in a rack, you'll be having 15 to 20 servers. So let's say we have 20 servers. Let's consider one rack is having 20 servers. I'll try to divide that into 4 parts. 4 physical parts, I can say. Physical means like logically, I'll try to divide them, not physically. Physically, it is one rack actually. So I'll try to logically divide that into 4 groups. 4 groups means 5 systems in one group, 5 systems in one group, 5 systems in one group, 5 systems in one group. Why they are dividing again that rack systems into category? That logical group, we call it as a update domain. That logical group, we call it as a update domain. That logical group, we call it as a update domain. Okay. Now, Shiva, why are they dividing that one? What is the reason for that? What is the reason for that? So this is one update domain. This is second update domain, third update domain, fourth update domain. 1, 2, 3, 4. Okay. What happens, ultimately or eventually, rack is nothing but it's a collection of systems, right? Okay. System is nothing but system contains some hardware and software, right? Sometimes they do patchwork, right? In systems. Patchwork means sometimes you'll get the hardware updates or the software updates, right? Some of the software updates requires rebooting, right? Even in your system also, whenever your system get updated, your system will get automatically rebooted sometimes, or it will ask you to reboot it. So if they reboot all the systems at the same point of time, then you will get a service interruption. So they don't reboot all 20 servers in a single shot. They will try to reboot like a group wise. That means first 5 systems, first they'll try to update, and once they are rebooted, they'll come to the second group. Okay, then second one will be updated, patch will be applied, and the systems will be rebooted, and this will be up. Once this is up, third one, and once this is also up, fourth one. They'll try to like update, they'll try to apply that patchwork or do that software updates or do that rebooting in a phases wise here. So those domains we call it as a update domain. Okay, now tell me at a high level, we have data center. Inside data center, we have actually racks like this. Okay, inside the rack, we have domains, fault domain, I can say. FD, I'm short form, I'm writing here. FD1, FD2, okay, FD3, like that, you may have any number of FDs here. FD3 and FD4, like this. Inside the FD, like you will be having 4 to 5 servers. Okay, server is the least like I can say component or least building block, I can say. The basic building block of the data center is a server. Group of servers will form a fault domain. Group of fault domains will form a rack. Group of racks will form a data center. Try to understand the hierarchy here. I'll keep asking the same question for next 1 hour. Okay. Any question here so far?
Can you please repeat that? Sure.
Okay.
The hierarchy.
Hierarchy. Okay. So in a data center, that means it's a physical building, I can say. In a physical building, you will be having racks like this. first rack, second rack, third rack, fourth rack, like that, and so on. You may be having 100 to 200 or 300 racks also in a data center, depending on the size of the data center. Okay, I'm not giving any guarantee that, okay, in a data center, you'll be having only 200 or 300 racks. That depends on the size of the data center. Okay, now inside the rack, actually, you'll be having fault domains. That means logically they're dividing systems into, they're dividing the systems into logical group. That logical group, I'm calling it as a fault domain, because all these systems will get updated or rebooted at same point of time. So inside the rack, you'll be having fault domains. Inside the fault domain, you'll be having systems or servers or nodes, whatever you call it. I can say server it. Server is the apt word, I can say. Correct word. Okay. That means server is a basic building block of the data center. Group of servers will form a fault domain. Group of fault domains will form a rack. Group of racks will form a data center.
Yes, got it. Thank you.
Okay. Moving on, guys. Just a second. Just a second, guys. Don't scribble my screen, please. I don't know who is that. Next. This is what I was saying actually. Okay. So this is one fault domain. This is one fault domain in the same rack, I can say. Fault domain 1, fault domain 2, fault domain 3. All these are logical categories, I can say. In the same rack, I can say. This rack is connected to the same power supply, same network. Okay. That is one thing. Okay. I'll tell you one small issue, guys, here. You guys, please try to comment on that. Let's say I've taken one service from this data center. Okay, I have a data center here. From this data center, I've taken a service. Let's say I took one VM from this data center. So remember one thing here. Whenever you take any service or whenever you try to store the data in the cloud, they will try to maintain 3 copies of your data, not single copy, 3 copies. Along with the primary copy, they are going to maintain 2 more copies, backup copies, I can say. This is secondary copy, this is tertiary copy. Okay, let's say you are storing some data in a sales table. They don't store like your data in a single server. They'll try to store the data in different servers. Here one copy, here one copy, here one copy. This is primary copy, this is secondary copy, this is tertiary copy, I can say. If you want, you can increase these replications, you can increase it, of course, no problem. Okay, the more you increase the replications here, the more the cost will incur, of course. Okay, that's okay. Let's say all my backup copies are in the same data center. All my backup copies are in the same data center. Okay, consider in the same rack, not in the same data center, consider same rack. All 3 copies, okay, first copy is here, second copy is here, third copy is here. Third copy is here, in the same rack. Primary copy, secondary copy, tertiary copy. Okay, what if something goes wrong with this rack? Your data is gone. Your data is gone.
Oh, we
Gone.
have gone.
Come on.
We have other update domain, right?
See, primary copy I maintain in the update domain 1. Secondary copy I maintain in the update domain 3. Third copy I'm maintaining update domain 4. Now, suddenly something went wrong with this power supply.
Okay. In that case,
And
yeah.
some failure happened because of some reason. Then your data is gone. So what they will do is you can happily like store your data like this, no problem with that. But they don't do like that. What they will do, in order to achieve more high availability, they will try to maintain one copy here, another copy here, third, I mean, consider this rack 1, rack 2, rack 3. Okay, another copy here. Fault domain is different, update domain is different. Fault domain is nothing but a rack. Update domain is nothing but it's a part of the fault domain, I can say. Subset of the fault domain, I can say. Okay, first copy here, second copy here, third copy here. Is there any chance that all these 3 racks will go down at the same point of time? Is there any chance all 3 racks will go down at the same point of time? Chances are high.
Yeah, sure. It can happen.
It can happen, but chances are bit less, right?
Less, yeah. Not high.
Not high. Chances are less. That means your data is bit, like I can say, your data is highly available, I can say. Okay. Okay, fine. Fine with that one, Siva. That is also okay. That is the reason why they don't maintain all 3 copies in the same rack. Okay. Instead of that, they'll try to distribute that into among the racks. That's fine. Okay. Siva, I have one data center in, let's say, Chennai. Let's say Chennai. Okay. All of the sudden, some tsunami came. Okay. And something happened to that entire data center. Entire data center is down, completely down. Or some fire accident happened in that building. You cannot predict them, right? So something may happen. Nobody can predict that. Nobody can stop that. That is tsunamis and the earthquakes are natural calamities. You cannot stop them. Then, in that case, how far your data is available? How far you can give the guarantee on your data? You cannot give that. So they don't store your data in a single data center. Agree? Agree with that? Of course. You just have to agree.
Yes, yes.
Okay. Okay. Fine. Fine with that one, Siva. Moving on. Then next thing will come into picture here. For that only I'm trying to explain all these things. That is availability zone. You need to understand this terminology also. Okay. You know why availability zones came into the picture? I told you if something goes wrong with entire data center, like my data is gone there. I mean, my cloud is not giving any guarantee if I try to store the data in the same data center, I can say. So that is the reason why at next level they came up with the availability zone concept. You know what will happen here? What will happen here? Here, availability zone is nothing but it's a big area, right? I can say here availability zone is nothing but group of data centers. We call it as a availability zone. One availability zone. One availability zone. Group of data centers. In that availability zone, you may have one or more than one data centers. Try to understand. I'll repeat that point. I'll repeat that point. Group of data centers will form a availability zone. In that availability zone, you may have only one data center or more than one data center. You may have 2, you may have 3, you may have 4, you may have 5 also. All 5 data centers together, they call it as one availability zone. Okay, here also, you may have like availability zone here. You may have one data center or more than one data center. That we call it as a availability zone 2. Here also, one or more data centers. That I call it as a availability zone 3. In general, in a region, you may or may not be having availability zones. I'll talk about the region. Don't worry about that one. I'll explain about that. Just try to understand. In a region, you may or may not be having availability zones. You may be having only one data center. I don't call it as availability zone. Okay, and that too, if you have availability zone concept in that particular region, definitely you will be having 3 availability zones. Definitely you'll be having 3 availability zones. Okay. Now, what I will do is I'll try to like maintain one copy of my data in this availability zone. I will try to maintain secondary copy in this availability zone. Third copy in this availability zone. What is that you're trying to achieve here by saving like that? What is that you're trying to achieve here?
High availability.
High availability. That's it. Is there any chance that all the availability zones will go at the same point of time? See, here you may have more than one data center. Here also you may have more than one data center. This is in different region. This is in, so this is in different place. This is in different place. This is in different place. Is there any chance that earthquake will come in all the regions at the same point of time? Fire accident may happen at the same point of time in all the data center. Is there any chance?
No.
No chance. So you are achieving actually high availability here. So you can store the data like that also. So now tell me the hierarchy. What is the basic building block of the data center? Server. Group of servers. Come on, I am expecting answer from everyone, please.
Fault domain.
Update domain, not fault domain. Update domain. Okay. Now group of update domains will form fault domain or rack. Okay, we call it as a rack. Now group of racks.
Data center.
We call it as a data center. Now group of data center. Logical group means it's not a physical group, I can say. Logical group. Okay, group of data centers together, we call it as a availability zone. Okay, if you have availability zone concept, then definitely you'll be having 3 availability zones in that region. That is what you need to understand. Okay, one copy you can maintain here, one copy you can maintain here. Not only data, guys. You can take one service from here, another service from here, third service from here. See, if you want, you can take that choice where to take it, or you can leave the choice to the cloud also. I'll show you. Practically, I'll show you how they're giving that choice.
You mean the pick up in the data from this out of these 3 servers, anywhere it will be picked out without our choice, right?
No. Where to store the data, that we can decide. Okay. Primary copy, secondary copy, tertiary copy will be decided by cloud only, not by us.
Acha, that is not by decided by ourselves, right?
Yes.
Okay.
Yes. Okay. Where to store, that you can control. Somewhat you can control, not fully. Partially you can control that, not fully.
Okay.
Okay. Yeah. Come on, once again repeat that. The hierarchy. Server after.
Update domain.
Group of
Update
servers.
domain, fault domain, data center,
Data
availability
center.
zones. Availability
Availability.
zones. Next. You guys know like why they came up with the availability zone concept. Okay, if something goes wrong with one data center, like your entire data will be lost actually. Because of that reason only, they're trying to divide the data center logically into availability zones, and one copy they'll maintain here, secondary copy here, third copy here. Because of that reason only, I explained all these things here. Okay. Now next. I'll tell you one more good thing guys here. I'll explain that one after the regions concept actually. Okay, no problem. See, some organizations require high availability, like more high availability, I can say. Okay, so what we are supposed to do is, if you're trying to store the data, one copy you'll maintain here, one copy you'll maintain here, one copy you'll maintain here, second copy you'll maintain here, third copy you'll maintain here. That is the general like understanding actually. Now my organization needs more like high availability. Okay, then what they will do, they will try to maintain one copy here, second copy here, third copy here. What is this actually? What is this actually? This is completely different region. Now region concept will come into picture here. Okay, two copies they'll try to maintain in the same region in two different availability zones. But third copy, which is far away from this particular region, okay, there they are going to maintain third copy. Is there any chance that all three availability zones will go down at the same point of time? Chances are less or chances are high?
Yes, it happens. Yeah, we face these issues.
It may happen, but chances are very less, right? Very
Yeah,
less,
if
right?
you
See,
say that in a year, we had a couple of times we had outage. So
even if you have outage, they'll try to immediately bring up those things from the backup servers or backup storage, I can say. Okay, it's cloud responsibility to bring it up. Okay, so chances are there, but chances are a bit less actually, I can say. Okay, because these two regions are separated by at least 300 miles. At least 300 miles. Okay, so even if you get the earthquake here in this region, your data is safe here. Even if something happened, like let's say some tsunami came in this region, nothing will happen. Your data is safe here and here. Okay, now one more next category I'll try to explain here, that is region. Okay, now let me just a second. Yeah. Now group of availability zones will form our group of availability zones. Together we call it as a region. This is the last one, guys. Last but one, not last one. Okay, region. This is what I was telling right here. Okay, let me try to use that one here. Yeah, see, I am calling all three availability zones as a region, Azure region. This blue color one, I call it as a region. That means in a region actually you'll be having availability zones. But condition is, in a region you may or you may not be having availability zones. You may or you may not be having availability zones. There is no guarantee that you need to have availability zones in that region. Please go on mute, please. In a region, you may or you may not be having availability zones in that particular region. Just a second. In a region, you may or may not be having availability zones. But Shiva, if you don't have availability zones, then what else we have in that region? We have only data centers. We have only data centers. Group of data centers also we can call it as a group of data centers also we call it as a region only. In a region, you may have availability zones or you may have only data centers. But in every region, there is no guarantee that every region contains the availability zones. Every region contains only data centers. Some region contains only data centers, some region contains only availability zones. Okay, let me tell you an example. In India, actually we have three regions. Yesterday we have seen, right? Now tell me what is the first region? Central India. That is the first region.
Mumbai.
Central India. No, I'm not asking the place actually. Region names. Region
North
names.
India.
Okay, second one. Second
South
one.
Central.
South Central is there. Okay, Central and South Central both are different. South Central is there. South
And
Central
South.
and South also there. Okay, third one is South is also there. South region. Okay, only in the Central India, region. These three are regions actually, guys. These three are the regions, not data centers. Regions. Okay, only Central India contains availability zones. Rest all contains only data centers. These two. Got it? And one more thing, there is no guarantee that every availability zone or every data center contains all the services. Let's say I wanted to take virtual machine service. That is also, see, virtual machine is also a service. Storage is also a service. Your ADF is also one service. Databricks is also one service. Everything is a service here. So there is no guarantee that every data center contains all the service. Every data center provides all the services. Some data centers may provide only some services. Some data center may provide only few services. Some data centers may provide all the services which are supported by Azure. Azure has actually more than 200 services. 200 plus services are there. Services, not data centers. I'm not talking about the data centers. I'm talking about the services. ADF is one service. Storage account is one service. Databricks is one service. Key Vault is one service. Like streaming service is one. Your Event Hub is one service. Your Logic App is one service. Power Apps is one service. Like that, different services are there. So there is no guarantee that every data center, every availability zone has all the services. That is also one more point you need to understand. Now come on, tell me the hierarchy. Repeat the hierarchy now. Server.
Update.
This is the least. Under server, group of servers will form.
Update.
Now group of update domains. Fault domain or rack. Okay. Group of racks.
Data center.
Data center. Now group of data center.
Availability zone.
Availability zone. And
Array.
this one I can call it as region. Region. Okay. And one more thing. Group of availability zones also we call it as a region only, right? Correct or not? Group of data centers also I can call it as a region. Group of availability zones also I can call it as a region. Anything is okay. One region may contain availability zones, may contain only data centers. Okay. Now, I told you right, in India we have three regions, right? Central India, South Central, and South India. Like the three regions are there. All three regions we call it as a next category, that is, can you guys guess? Can you guys guess? What is that? Geography. Okay. I'm calling it as geography. Geography. You call it in any way. Okay. US is one geography. India is one geography. Singapore is one geography. Malaysia is one geography. Like that, a group of regions, we call it as a geography. This is the last one actually. Now I'll tell you the hierarchy here neatly. Let me go there. This is the one I'm talking. Okay. So in a data center, you'll be having fault domains and the update domains. Group of data centers will form actually availability zones. Group of availability zones, we call it as regions. In a region, you may or may not be having availability zones. Group of regions, we call it as a geography. Example, India, U region, Northeast region, and Southeast region, something like that. Different regions are there. Different geographies are there. Okay. Now let me talk about few things here. Let me talk about few things. Shiva, why they are trying to, why they are establishing or why they are spreading their data centers across the world? Why can't they establish all their data centers in a specific country, in a specific place where the cost is very cheap or maintenance is very cheap? Are you getting my question? Are you getting my question? See, this data, see, Microsoft has more than 200 data centers, right? They spread across, see, almost we have 195 countries are there. 195 plus countries are there. 190 plus, I can say. I'm not sure the exact number here. Okay, I'm guessing it is a 195. Almost in all the countries, they have data centers. Almost in all the countries, 150 plus countries, they have data centers. Why they have like data centers in all the countries? Why not in only specific country?
To reach out the latency data.
Exactly. Very good point. Very good point. Latency means, in your point, what does it mean actually?
Whenever we access, right? So it has to come immediately.
Yeah, good. Whenever you upload the data, whenever you try to access the data, they have to, like, you have to get the data from the nearest location so that you will get the response very quickly. That's what you meant to say, right?
Yeah.
So that is one point. Okay, absolutely. Very good point, really. Next. Just guess it, no problem. Even if you say wrong one, wrong point, I don't mind. Just guess it. Okay, let me talk about that. Let's consider, I'm just giving casual example, guys. Please don't take that. Okay, let's consider Microsoft has decided to establish or start their data centers only in Pakistan. Pakistan has offered Microsoft saying that, hey, Microsoft, we will give you manpower. We will give you like land to you. Okay, you establish all your data centers in my country only. What are all the government subsidies are there? We'll try to give all the subsidies to you. Okay, you establish everything in Pakistan. Okay, Microsoft has established all 200 data centers in Pakistan only. Let's consider the scenario. Okay, now let's say, now India, one of the bank, let's say, like first bank in India which has stored the data in a cloud is SBI, State Bank of India. SBI. SBI is actually storing your data in a cloud. Now SBI has decided to store the data in Azure. Okay, now SBI people contacted Microsoft people. Dear Microsoft, we wanted to store our data into your data centers. Now, how much cost is this? They took the cost estimation and all. They're ready to store the data. Okay. Now, government of India has objected SBI. Was how come you're going to store your data in Pakistan? How dare you to do that? What if Pakistan hacks the data? What if everything goes wrong in that particular Pakistan country? Who is going to give that guarantee? I will not tell you to store the data. Go to hell. This is the issue actually. So every country has some data governance rules. I told you already in one of the class, GDPR. What is that full form of GDPR? General Data Protection Rule, something it is there, right? That is what I told you, right? Every country has to follow these rules. Our data, our Indian people data, our Aadhaar card data should not cross my country, should not go out of the country. You should not store the data in a Pakistan. You should not store that in a China. You should not store that in only US. It should be there only in my country. If you have data centers in our country, you go and store it happily. Then only I will allow you. Otherwise, I will not allow you. Government will not allow. So that is one more reason. Data governance is the biggest reason actually to spread these data centers across the world. So every country has their own GDPR rules. Okay, that is one point. And one more thing. One more thing is the tax rates and subsidiaries are same, are same across all the countries, or they differ? Tax rates and the subsidies, government subsidies. Are they same in across all the countries in the world?
No.
No. No. They're different, completely different. Okay. So that is also one of the reason. They don't want to establish their data center in a specific country where they don't have manpower, where they don't have government subsidy, where they don't have the data governance rules. They don't want to do that actually. They wanted to they wanted to establish their data center almost in every country so that they can achieve this GDPR data governance, so that they can achieve okay, some countries may be costly countries. Some countries may charge more from the Microsoft. Some countries may give more subsidy. They will balance that actually. The countries where the government is giving more subsidy, Microsoft will get more profit there. The countries who are like where they are charging more from the Microsoft, they are going to get less charges from there. That is the reason why when I was showing the the Snowflake cost, Snowflake charges will vary from region to region or not. Correct or not?
Yes.
Did I tell you that point or not? Yes. Snowflake cost always vary based on the region that you choose and the edition that you select. If you select like Mumbai region, you'll get one charge. If you select US region, you'll get one charge. They're going to charge a little bit different. So charges are different region to region. That is also one of the reason. Okay, so because of that, actually, they don't establish all those data centers in a one country. Government will not allow that. Countries will not allow that actually. And that too, one more reason is like Chandu said. Let's say I'm in India. SBI people are doing the transactions. The transactional data, let's say I'm trying to store it in a Azure SQL. Azure SQL. This is cloud SQL server actually. Azure SQL is nothing but a cloud SQL server. Let's say every transaction I'm trying to store it in a Azure SQL database. Let's consider this Azure SQL. I've taken it from the US region. When you do some transaction, let's say I withdraw some amount from my bank. That is nothing but a transaction. The transaction has to be noted in that particular database. That means this transaction has to travel all the way from India to US. That will take more time. Of course, even though it is milliseconds, every millisecond is important for them. Every millisecond is important for them. Okay. And well, let's say I wanted to do some analytics on top of the data, transactional data. Now I wanted to extract the data from that particular data center, which is there in the US. If I want to extract the data, you're sitting in India and you're trying to extract the data from the Azure SQL, then the data has to travel all the way from via network from US to India. The latency is more. The latency is more. This is also one of the reason. So most of the US companies actually, they select the region as US regions only. Most of the Indian companies select their cloud region as Indian region only. Because of the latency. Just able to get it. Next, moving on. CapEx and OpEx is also there, guys. This is not that important actually. If you want, I can explain then, or you can leave it. No problem. That's okay. You can leave it. I don't want to spend time on that. Next. Any questions so far? Yeah.
So
Okay.
Shiva, that is recommended also, right? Same region to select the same region.
Yes. Nearest region. Selecting nearest region is a recommended approach actually.
I have a question. Like, as you said in our example, State Bank of India want to, say, store their data in data center. So, is Snowflake is going to provide any specific data centers within India? For example,
No.
because if you
Like,
take AWS and if you take
uh,
American, the government projects have the special data centers, especially in United States.
yeah, I'll
Those
talk
we,
about that one as well. I'll talk about that one as well. Special
so do
data
you have,
centers are there. I'll talk about that. Yeah. It's there in my slides actually. Let me show you that.
no need to show. We will go according to your flow. Just I have a question.
Yeah. I am supposed to cover that. Yeah. This is there. I'm supposed to cover that before I get into this actually. Yeah. Thanks for reminding that. Okay. See, first let me cover this, and after that I'll get into that special regions. Azure has actually 60 plus announced regions so far. Regions, not data centers. Regions. 60 plus announced regions. More. That means Microsoft is the biggest. Microsoft is the biggest cloud provider actually. I can say than AWS. Azure makes it easy to choose the data center and regions that are right for you, for your customers. Okay. Microsoft Azure has presence in 60 plus regions worldwide and available in 140 countries. Yes, I told you, right? 150 countries. This could have reached 150 definitely, because I prepared these slides actually 1 year back almost. By this time it could have reached 150 definitely. Okay. And one more thing is, all the data center within a region are connected by low latency network. That means they can talk each other with a latency of less than 2 milliseconds. Less than 2 milliseconds, not seconds, guys. 2 milliseconds. 2 divided by 1000. 0.002 second. That is the latency between data centers. Any data center can talk to any other data center in the world. All are interconnected. How you're connecting the systems, in the same way they connect the data centers. Okay. So these are all the actually different regions where Microsoft is providing that data centers. Okay. In India, actually, we have 3 regions, right? That is Central India, South India, and West India. It was there actually previously. I told you, right? 1 year back, we used to have West India also. Now they made it actually South Central. It's not West, it's a South Central now. I need to update my document. Okay. Most of the regions they have in US. South Central US, West US, West US 2, West US 3, Central US 2, like that. Different regions are there. Most of the data centers are there in US, because Microsoft is a US based company. They started the cloud from there on. And some of the data centers are like government data centers, government regions. I'll talk about that one. Okay. We have special regions, guys, actually. Okay. I told you, right? Region selection always. A region should be near for low latency. We always need to select the region that is near to your location. Not all the, okay, we need to check whether your region contains the selected service. Is that region is providing your service or not? That also you need to check. I told you not all the services are available in all the regions. And that too pricing may vary from region to region. Okay. And you need to check whether they are zone enabled or not. If they are enabled zone, then your data protection is little bit more. I mean, more high availability, you're going to get it. More high availability. Okay. And you have some special regions actually, especially for the government actually. They store only government data, not private data. They're not public actually. And while you guys are selecting a region, when you guys are creating a service, right, you will not be able to see these regions because they're specially created or established for government. Okay, example for that one is US government Virginia and US government Iowa. Okay, so these are the special regions I can say, and some special partnered regions are there. I'll talk about that one as well. Okay, our neighboring country China, they don't believe any other country. They feel that if they store their data in US region or if they store their data in India, they feel that okay, they are stealing the data or they're hacking the data. Other countries are hacking the data. They feel that their data is too precious, too value, I can say. Okay, so they don't allow directly Microsoft people to establish the data centers in China. Okay, what they do, they'll tie up with the Microsoft. They'll go to the Microsoft and they'll say that, hey, Microsoft, you can come and establish your data centers in our country, no problem. But you have to follow some terms and conditions. Okay. What is that terms and conditions? You establish that one, you maintain everything. You maintain means like you try to establish everything in our country. We are going to maintain that. You don't maintain that because we don't believe you. You're from US. We don't believe you. You may hack our data. So you can come and establish that, but we are going to maintain the data centers actually. We don't give you that choice. Okay, you and me are partner on partnership basis. We are going to maintain that. So like that, China has some special regions, and even Germany has also some special regions. Okay. These things about the special regions that Hari was talking. Hari, did I cover everything?
Yes.
Yeah. Yeah, that is one thing. And one more thing I need to cover, guys, here. That is region pairing. Okay, this is also a bit important one actually. Region pairing. So what is this region pairing actually? Pair means two. Okay, two regions, we call it as a region pair here. Okay, this is one region A and region B. Okay, you know why every region pair is always situated at the distance of more than 300 miles. This point is important here. Okay, you know why they are paired up here? Even in the India also, you have one pair region is there. If you want, you can search it in Google. Okay, date in almost in all the countries, actually, we have that region pairs, except in Brazil South. Okay, they have some government issues there. They because of that, except that, remaining all the countries has that region pairs. Okay, you know what is that reason here? What is that reason of having this region pairs here? If they get any updates in the software of Microsoft systems, like in operating systems, I can say, Microsoft operating systems. Let's say you have taken one service from this region, another service from this region. They don't apply that update or they don't apply that patch in on these two regions at the same point of time. First, they'll try to apply that patch or update on all the data centers of this region. Once this is completed and once this is up and running, then only they'll try to do that one in the region B. Because if they try to do that updates or patchwork in both the data centers at the same point of time, what if customer takes the services from both the data centers, from both the regions? Let's say I've taken one VM from here and another VM here. If they're restarting all the system from both the regions at the same point of time, my VM will go down. I cannot able to access my VM. I cannot able to access my compute power. That doesn't make any sense. For that reason, actually, they don't apply that patches or software updates or upgradations and all those things they don't apply on a in a single shot in multiple regions. They'll try to go in a shift wise, I can say. First in one region, after that in the second region. So these regions we call it as a region pairs. Okay, these region pairs separated at least with 300 miles. At least. Okay, this is what I was telling. Central India paired with South India. Southeast Asia paired with the East Asia, like that. Okay. That is about the hierarchy and the data centers and all. Let me talk about this one as well. Let me try to complete this one as well. 4 more slides are there. They're very easy here. Let's try to understand it. Okay. Based on how you are storing the data in the data centers, we have different like storage based disks are there. Storage account based disks are there. One is LRS, ZRS, GRS, RAGRS. Guys, this is very important one. Please try to understand. Please try to focus here. Because we are going to get same options in the Azure. While creating the services, actually, you will get these options. I know even in the real time also, many people doesn't know what exactly mean by LRS, ZRS, GRS and the RAGRS. They blindly will go and select the RAGRS. And they don't know the impact of selecting this one. Okay. Now, first one is LRS. The full form of LRS is locally redundant. The full form of ZRS is zone redundant storage. GRS full form is geo redundant storage. Okay. RAGRS full form is read access geo redundant storage. Okay. Now let's try to understand one by one. The first one is LRS. Oh, sorry, LRS, right? Yeah. Sorry, sir. This is the one. Okay, where is that? This is the one. LRS. what we do here is, when you try to store your data in the data center, all 3 copies of your data, you're going to store it in a same data center. 3 copies you're going to maintain in a 3 data centers. Shiva, why are we going to do that one? What is the advantage of doing this? If you store, if you maintain data like this, then they'll give, they'll charge very less cost from you. They don't charge that much from you. Because they, whenever you try to access the data, they'll try to interact only within the data center. They'll try to interact between or among the racks. Okay, but the high availability or the durability that they're providing is 99.9999 up to 11 nines. Up to 11 nines. Guys, you think about one thing here. Do you think here first copy will be stored here, and after that, after some time, second copy and third copy will be stored in the data center? Do you think like that? No. Once you upload the file, see, we were uploading the files into S3 bucket, right? I mean, 20 days back or 25 days back or 1 month back, we were trying to upload the data into S3 bucket. Once you upload the data into S3 bucket, what was the message you're getting? Successfully uploaded. Why are you getting that message actually? What do you mean by that? Once you upload the file into S3 bucket, once they upload the data, once they copy that primary copy into the data center, they are displaying that message? No. So simultaneously, they will try to copy the data into 3 different tracks here. First copy, second copy, third copy. Whenever the copy is done, once you successfully, like synchronously create the 3 copies of your file, then only they will display successfully uploaded. That synchronization cloud will take care. You don't need to do anything from your end. You just need to mention the number of replicas. Getting? But the disadvantage of storing the data like this is, if something happened to my data center, that's all, your data is gone. So do not store your sensitive data in a single data center. So this is not a good option for sensitive data. Only, this is good only for the non-sensitive data. But the cost is very less. Cost is very less. Okay. Next one is ZRS. See, in the first case, we are maintaining 3 copies in the same data center. Same data center. In the second case, 1 copy in one availability zone, another copy in another availability zone, third copy in another availability zone. Okay, what about the cost and what about the durability or high availability? Are we going to get the more high availability than LRS here, the ZRS? Yes. How much they are giving here? LRS was giving actually only 99.9999, only 11 nines. ZRS is giving 12 nines here. That is the durability. That is the high availability they are giving. Chances of going down, chances of losing your data, 0.000000001. Only 1/10th of your LRS chances. Okay, here also we don't get any guarantee here. Your entire region may go down, because in the region I have these availability zones. Entire region may go down here. That also may happen. So how many copies you are maintaining here? 3 copies. Now I'm moving on to the second one, third one, that is GZRS. Sorry, second one is actually ZRS, right? Third one is GZRS. GRS or GZRS. The full form of that one is geo-redundant storage. That means one copy you'll maintain in, this is region pair case actually. That region pair I call it as a primary region, secondary region. In the GRS and the GZRS, we are going to maintain 6 copies total here. 6 copies. This is the costly option compared to the ZRS and the LRS. Because you're maintaining 6 copies here. Okay. First 3 copies you're going to maintain in one data centers in a primary region. Second 3 copies actually, second set actually, you're going to store it in a second another data center in a secondary region. Completely different regions, not in the same region. See, previously we were storing the data in the same region, but in here we are trying to store our data in a different regions. But previously we were maintaining only 3 copies, but in this case actually we are maintaining 6 copies. Because of that, it is a costly one. And even cloud also like need to synchronize between these 2 regions. For that they are going to charge more. But these people are because of this option actually, the high availability you are going to get is 16 nines, 99.99 and up to 69s. Now, high availability point of view, this is better than LRS and the ZRS. Cost point of view, this is costly one, I can say. This is not good when you compare with the LRS and ZRS. But if at all, if you want to store your sensitive data, which is critical for your business, you try to select the GRS, not the LRS. Based on the sensitivity of the data, you go ahead and select the option. Okay, and the last one is, this is GRS and the last one is GZRS. Geo Zone Redundant Storage. Name itself indicating. And your region and as well as zone. Both are trying to involve here. Okay, here we'll try to store the data in 2 different regions only. Primary copy. I mean, first 3 copies actually, I'll try to maintain in a availability zones. In first availability zone, 1 copy, second availability zone, 2nd copy, third availability zone, 3rd copy. And next 3 copies, I'll try to like maintain in a secondary region in the same data center actually. Same data center. Okay. Now, compared to the GRS, these people are giving more high availability, I can say. Okay, the most costly option is GZRS. And the most best option for the sensitive data is GZRS. Least cost one is LRS.
Siva,
But
come again.
you cannot
said,
store sensitive data here.
Siva, come again. You said that GRS is on the same region. It should be in separate regions, right?
Separate regions only, yeah.
Okay.
But the copies actually they'll try to maintain in a availability zone. But previously, where were we maintaining here? This one data center only, right here. One data center only, right here and here. But here be different. Okay. Yeah. That's all. These are the basics of the Azure. Okay. Tomorrow we will get into I can say the basics of the ADF. Before that one, I'll just high level show you what are all the different services are there in Azure related to data engineering. Can I go ahead or can we continue?
Yeah, Siva, I have a question here. Yeah, again, it may not be relevant, but just I'm curious because about the storage cost. So when we have 3 copies, how do they charge? Any idea? Because I have an idea because I know how much we pay for terabyte of data. But will the Azure charges only for 1 copy or will they charge us for all the 3 copies?
But they show only one rate.
Yeah.
Only one rate. Let's say, Snowflake people are saying that for 1 TB we are going to charge $24.
Yep.
Okay,
whatever,
they don't charge
upon.
24 into 3 or 24 into 6.
Okay.
1 TB, they are going to charge only 24. See, it's their responsibility to maintain these replicas, right? Because they have to give that guarantee to me. Otherwise, why should I store my data in their cloud?
There is a lot of technology involved in storing the data. Actually, for example, if they say that if they have 2 or 3 copies, for example, 1 terabyte of data doesn't mean that they need 3 terabytes of space. We have RAID 0, RAID 1. There is a lot of technology, storage technology involved in it. Even though if we have 1 terabyte of data, we can have 3 copies on it if we have 1.3 terabyte of space. So we'll have 3 full copies. So that is called, if we go to depth into the storage, then we can understand. What I mean to say is for 1 terabyte of data, if we want 3 copies, there is no need to have 3 terabytes of space. 1.3 terabyte of space is more than enough. Yeah. As you said, I think it's their headache to maintain. How they maintain, we'll pay like as you said, right? Yeah.
But at high level, they say that okay, for 1 terabyte we charge only $24. That's it.
Correct. Yeah. Our data totally, when I calculate, we say we have 30 terabytes. We have more than that. Just I'm throwing some example. So we pay for that 30 terabytes each month. Yep.
Yes. Okay. Yeah. Any questions, guys, before I get into? Shall we stop here, or can I go ahead and continue?
Yeah, Siva, if you don't mind, can you please? Maybe I missed it. Can you share actually what you are going to teach us? I know that my friend told me it is ADF. Yeah, I'm interested in learning that. Having some idea. Just can you give us a overall, please, for the whole class? What will be your classes like going forward?
The content of the ADF.
Yes, please. No, your whole whatever you are teaching from now onwards for the next whatever weeks you are taking the class, please.
That's what. Okay. In ADF, what I'm going to teach? That's what your question, right?
The whole content of your course. Yep.
Yeah. Okay. So first, I'll start with the basic buildings, basic building of the pipelines in the ADF. Okay, I'm going to teach actually ADF. Okay, and Azure Key Vault, AKV. Okay, and little bit of Databricks for project purpose. Okay, the project I'm going to cover ADF combination with Snowflake. Okay, I'm going to use Snowflake as a data warehouse. I'm going to use ADF as a ETL tool. I'll extract the data from on-premise databases. I'll try to use ADF as an ETL tool, and I'll try to store the data in like Snowflake. I'll do transformations with the help of ADF only. Okay, raw layer, stage layer, consumption layer, all 3 layers I'm going to maintain in Snowflake only with the help of ADF. Okay, these are the services I'm going to cover here first. Okay, of course, some of the other services also included here. I'm not at high level. These are the main services I'm going to cover for the upcoming month. This whole month, I can say. Okay, basic building blocks of the ADF. First, I'll start with that. Okay, first, I'll try to explore. I'll make you to understand about the activities which are important, which we are going to use in real time regularly. The activities which we are going to use regularly in our projects. That I'm going to discuss. Activities. With the help of example. No more theory concept from day after tomorrow, guys. Everything is practical only from day after tomorrow onwards. Since these are basics, I'm going with the theory and all here because I cannot demonstrate all these things here. Okay, from day after tomorrow onwards, everything is practical. No more theory part. Okay, so I'm going to cover that activities. And after that, I'm going to cover the transformations, how you are going to perform transformations in ADF. So almost we have 25 transformations are there in ADF actually. I'm going to cover all 25 transformations. All 25. If time permits. 22 transformations. If you guys cooperate. Okay. So once I'm done with this transformations and activities, I'm going to discuss about the parameterization. Parameter. This is most important concept in ADF. Many people doesn't understand this concept, but I'll make it easy. If you understand, then you'll get very good. You will build very good pipelines. Really. Today also in our project actually, another project people took my pipelines as reference in ADF, and they're really impressed with my pipelines. I'll demonstrate that one as well if you want. Okay. So that parameterization I'll try to explain. I'll make it easy definitely because this is the most toughest topic in ADF I can say. But for me it is damn easy. Okay, I'm going to cover that. Once we are done that one, I'm going to cover the project. Okay, project alone will take 1 week of time completely. Okay, before this project starts actually, I'm going to cover little bit of Databricks as well. Not completely. I can say 20% of the Databricks concept I'm going to discuss because these Databricks concepts are required for the project. Okay, 20% of the Databricks, not all. Not every concept in the Databricks I'm going to discuss. Okay, in the project actually, almost 1 week to like 1.5 week we are going to discuss. There, Snowflake, ADF, combination I'm going to teach. The same project you can have it in your resume. You can explain in your projects. You can explain in your interviews. If you want, you can check with your my students also. Some of them already there in this group only. Yesterday also one of the student has given the interview. Okay, there also he has explained the same project which I explained in the last batch. This is what the curriculum for the upcoming month.
So the DB tool.
Databricks. Databricks is a third-party tool actually. Okay, they are taking Azure help for the compute and the storage. It's a very famous tool I can say. Very famous. It's almost competitor to Snowflake. Almost.
It was once upon a time, not anymore.
Now also it is a competitor I can say. What are all the features are there in Snowflake? All those features they introduced.
So is it available in all the three cloud regions? Because I am not.
Databricks is available in all 3 clouds. Yes. Yes.
Okay. I'm ignorant a little bit about that, but yeah.
Yes, it is available. Now AWS Databricks is very famous. Very famous nowadays. Now they opened their eyes actually, AWS people. Azure actually, they launched the Azure with the Databricks combination long back, and it has become very popular. After that, after a long time, AWS has opened their eyes. Now they're promoting like anyway. Now they're promoting. Opens, vouchers, trainings, they're promoting like anyway in the LinkedIn, in their website as well. Because the combination is too good actually. Azure with the Databricks, Azure with AWS, Azure with GCP. So I'm running separate batch for this one, guys. See if I start teaching all these tools right, it will take 2 more months. Are you guys ready to take it? I'm okay to teach it. I'll charge only extra 5,000 from you. I'm ready to teach it. Are you guys have enough patience?
Yes.
Yeah, one at a time, Seba, one at a time. Though that way,
One
we
at a
learn a
time
little
only.
more.
First,
Yeah,
let
yeah.
me complete the ADF.
Yeah.
And after that, I'll get into Databricks.
Yep.
Including in the Databricks, I'll teach from the scratch, which nobody is going to discuss in the market. If you have patience, I'm ready to discuss that. Yeah. Any other questions here? Guys, you need to have cloud knowledge in the data engineering, especially. Please try to understand. And I'm telling you, I've been telling you the same point. Python is required. Python is required. Python is required. Without Python, nowadays, the interviews will becoming very tough. Very tough, really.
Yeah, more than ADF, we use a lot of Python framework, Shiva. That is one of the reasons
Yes.
why I'm joining that Python class. Yep.
Yes. See, why I'm insisting you to like join that in that class, right? At least you'll get basic idea, very basic idea. That is enough actually to boost. Okay, so please, whether you'll take the training with me or you take it outside, that's up to you. But Python is required, guys. I've told the same point in the day one also. Now also I'm telling same thing. Okay. Yeah, that's all for today.
All right. Thank you, Shiva. Have a good day or good evening. Good morning. Bye.
Thank you.